Kia ora Ben, Tosef and Snehal and anyone who's watching from 12 MCA. I'm going to start videoing old questions from past papers in kind of groups of topics that we've done. And Ben, Tosef and Snehal, you've done the sequences and series work. If you're watching this, anyone else in 2022, if you're in the AS class, you're about to do this. And then soon we'll do the level 2 NCEA internal that goes along with this work. So these questions basically come down to the formulae that I've put up here in the top of the thing. Sorry guys, that is not COVID, that cough, it's just a cough. So we've got two kinds of series and sequence. Arithmetic ones, where there's a common difference. And this first formula gives me the value of each term, and the next one gives me two different ways to find the sum of n terms. So where I'm adding up, say, the first 10 terms. For a geometric series, the link between terms is a common ratio. So we multiply the first term by a ratio r to get the next term, and then we do it again. So these formulae give us the sum. This one gives us the individual term, this one gives us the sum of n terms, and this last one, which is incredibly useful in lots of places in maths, is what we call the sum to infinity. So if the common ratio is between -1 and 1, then when we start adding up those terms, we find that they converge to a limit. Right? And that's an idea that you'll work with lots more when you do level 3 and scholarship calculus and university maths. Okay, so what I've got here is I've got all of the questions from the 2021 May-June papers, and I'll try and get through them in this video, but it might go into a second one. These questions are well worth mastering totally. They're very easy to muck up because they have often quite simple but messy simultaneous equations. So really, they're not that hard conceptually, but they are ones that are worth doing tons of practice on. The first one is a pretty boring one. We've got the sum of the first 20 terms of an arithmetic progression is 405, and the sum of the first 40 terms is 1,410. So you can guess that what we're going to have to do is to find A, the first term, and D, the common difference, and then we're going to use that to find the 60th term of the progression. So for the first question, the only thing we're going to be working with is the sum to n terms formula. And the one that I want to use is, I'm going to use this one. This is usually the one I'll use. This first one here is if I know the last term and the first term. But that's kind of an unusual setup, and I haven't come across that in a while. So let's take a look at what we've got. Well, we start by just writing down that the sum of n terms is equal to this. And then we're going to substitute in, and we're going to do that twice over. So the sum of the first 20 terms is 405. That gives me a half times 20, and we've got 2a plus 19d. Cleaning that up gives me 405 is equal to 10 times 2a plus 19d. And I'm going to do the same thing for the first 20 terms. So 1,410 is equal to a half of 40. So I've gone straight to 20 there, times 2a plus 39d. Now obviously lots of different ways to go here, but I noticed that I had this here and this here. So doing a little bit of rearranging, I got 40.5 is equal to 2a plus 19d. And then 1,410 divided by 20 gives me 70.5. And that's 2a plus 39d. Whoops, 39d, not 3d. Okay, so then subtracting number 1 from number 2 leaves me with 30 is equal to 20d. So d has got to equal 3 over 2 or 1.5. Now I can take that and I can substitute d back into either one of these. They're both a bit mucky. 40.5 is equal to 2a plus 19 times 1.5. What does that leave me with? That leaves me with 12 is equal to 2a. Right, working that out and subtracting it from both sides, giving me a is equal to 6. So that's good. We've got the first bit of that done. Now we're going to use that to find the 60th term. Right, so to find a term, I'm using this one here, a plus n minus 1d. So u60 will be A, 6, plus n minus 1, 59, times the common difference, which is 3 over 2. And you can see that I've relented and I'm using a decimal, guys, even though I hate them, because here it's a terminating decimal and it's just a tiny bit faster. So that gets me my final answer for the 60th term of 94.5. Now, I haven't actually checked that in the marked schedule. I hope that's right. I've checked the other questions in here. So that's the first one done. That's about as easy as it's going to get, but that was worth 5 marks, right? So that's a decent few marks on the board. Now, in the next one, question 5 from the same paper, so there were 2 sequences questions in this paper, is about a geometric progression, and this one is a little bit more fun. So we've given terms number 5, 6, and 7, and we're told that they are 8k, negative 12, and 2k, and it's a geometric progression. So that means that I know to get from here to here, I'm multiplying by something, and that's called r. To get from here to here, I'm multiplying by something, and we're told that k is negative. We have to find the sum to infinity of the progression. So in the end, I'm going to use this, and to do that, I need to have 2 numbers. I need to have a, and I need to have r. Right, I'm going to move over to this workspace. So I want you to try this question, pause the video and see how far you get with this one without watching, and then maybe put me onto like triple speed or something to go through it. So the ratio is constant. That's the whole point of it being a geometric progression. That means that I can take negative 12 and divide it by 8k. So the 6th term divided by the 5th must be the same as the 7th term, 2k, divided by the 6th. That gives me a way to find k, right? Now, I've been told that k is negative. I get 144 is equal to 8k squared. 8k squared? No, not 8k squared, 16k squared. 8 2s are not 8. 16k squared, so k squared is equal to 9, but they told us in the question that k was negative. So k is equal to negative 3. And now we can use that to find the common ratio. So r will equal, let's see, r will equal negative 6 over negative 12, which is 1/2. Now that should make you quite happy because we know we've got to find the sum to infinity. So if my r value had worked out as something that was, not between negative 1 and 1, I know that I would have mucked up. That's the first bit done. But I still need to get a. So what was the first term in my sequence? Well, I can pick any one of these now. I'm going to pick that negative 12. So we know that the 6th term was negative 12. And we know that that was equal to a times by the ratio 1/2 to the power of 5. Okay, so every time we move up a term, we times by 1/2. So we have negative 12 is equal to a over 32, which tells me my first term was a equals negative 384. So that's that bit done. All that's left to do now is to apply the sum to infinity. So the sum to infinity will be a over 1 minus r, which is negative 384 over 1 minus 1/2, which works out to be 2 times that, so negative 768. So that's that question done. Okay, there's no way I'm going to get through all of these in one video. I'm just looking to see if I can do the next one or if I should do a separate video. And I think I'm going to do separate videos for these questions, guys, because I want to go really slowly through them and use them for some revision work. So I'm going to upload now and come back later on today and do those next 2. If you see any more sequences and series questions that you're having trouble with, just shoot me an email and I can do some videos on them.